All right, tangents and normals. So half of this you've actually already seen before, tangents. We know all about tangents, and normals is pretty similar, so it's not too difficult. Right, so tangents. If we have a point on a curve and our function, our curve is differentiable at that point, then we can find the gradient, yeah? How do you find the gradient of a curve at any point? Derivative. Yeah. All right, the gradient of a curve. Say our curve is f of x. The derivative is f dash x, right? That's the gradient. The gradient of a curve when x equals a, for example, when x equals 3, how do we find the gradient at that specific point? Yeah, so we sub it in. So the gradient when x equals a is the derivative with a subbed in. All right, once you've got the gradient of the curve or the gradient of the tangent at a certain point along the curve, if you want to find the equation of that straight line, of that tangent line, then all you've got to do is y equals mx plus c. You know your m, that's the gradient, and you just got to figure out c. Okay. So we'll start, I think we'll start with the example. So find the equation of the tangent to y equals x cubed plus half x squared at x equals 1. Right, so how do we find the gradient at any point of the curve?
Find the derivative.
Derivative, yes, yes. So we're going to find the derivative. So what's our notation? Is it f dash of x? What notation do we use for derivative? dy dx, yeah, because our function's in y equals. So dy dx. What's the derivative of x cubed? Yeah. 3x squared, good. The derivative of half x squared? It's x, yeah. Right, so that's the derivative, that's the gradient at any point along the curve. So to find it, the gradient when x equals 1, all you have to do is sub in x equals 1 into that gradient. So when x equals 1, we get 3 times 1 squared plus 1. 1 squared is 1, obviously, so you get 3 plus 1, it equals 4. So that's the gradient of the tangent line. Okay. Now we have y equals mx plus c, right? Because our tangent is a straight line. Y equals mx plus c. What do we know? What did we just figure out?
M.
We figured out m. We figured out the gradient. So we can put that in there. What else do we need to know to figure out c?
1.
Yeah, we know x, it's 1. We need to know y. So what is, when x equals 1, what is the y value at that point? Why would you say 0?
Oh, I can see the line functions.
That's assuming that that is a x-intercept, and it's not. No. Right, given an x value on a line, how do you find the y value? Sub it in, right, to the function. So it's this function here. It's going to sub in x equals 1. So y equals 1 cubed plus 1/2 1 squared. So we get 1 plus 1/2. It's 1.5. Right, so it's at the point 1 and 1.5. Right, so we know our m, we know our x, we know our y. All we have to do is figure out c by subbing them in. So we're going to sub in the y value, 1.5. Going to sub in the x value, which is 1. And we're looking for c. Right, so c, we take that 4 on the other side, get 1.5 minus 4, which is negative 2.5. Yeah, so negative 5 on 2. Right, you know your m, you know your c, you can now write the equation of the line. So it's y equals mx plus c. So all you're doing is just like normal, you find the derivative that gives you the gradient of the function at any point. You want to know it for one certain x point, so you sub in that x value to find the gradient at that point. From there on, it's just a case of linear equations. So you chuck in your m, you got to find your x and y coordinate, you chuck those in, you solve for c, and that's it. Okay. Right, normals. A normal right, a normal is the name we give to the line that is perpendicular to the tangent. Perpendicular to the tangent. So it's a straight line. What does perpendicular mean?
Cuts at 90 angle.
Yeah, cuts at a 90-degree angle. Yeah, so it'll go straight through the point. So you know how the tangent kind of touches the curve at a point? The perpendicular line, the normal, goes straight through that point. Okay, so if the gradient of the tangent is a over b, the gradient of the normal is, now I don't know if you remember this from year 10, a over b, you flip it and you change the sign. So it'd be negative b on a. So, given our equation that we worked out before, which was y equals 4x minus 5 on 2, that's the tangent line, and it touched the curve at 1 and 1.5, right, so that's just from the previous example. We have to use that to figure out the equation of the normal. So what's the gradient of the tangent line? As a fraction is 4 and 1. So a over b equals 4 over 1. So you flip it, change the sign. So our new gradient is 1 on 4 with a negative 1/4. Just flip it, change the sign. If it's already a negative, make it a positive. Right, so that's the gradient of our normal. So far we know our m. How are we going to figure out C?
So x with 1. And y with 2.
Yes. Right, you just take a point you know that lies on that normal line, which is that point there, and you sub those into y and x. So we've got 3 on 2 equals negative quarter times 1 plus c. So rearranging, we get 1.5 plus quarter, which gives us what? A number, yes, which is, yeah, we've got 6 on 4 plus 1 on 4, 7 on 4. So our normal equation is negative 1/4 x plus 7/4. Right, so it's all pretty much just a case of a little bit of derivatives and y equals mx plus c. Are there any questions? No? We're all good? Okay, great.